For this problem, we want to look at maximizing profits. And we want to look for maximizing profits. I want to find the absolute max, but we want to look on a closed interval. So here we're asked to find the maximum profit that can be made on an apartment complex that has 100 two-bedroom units. And the minimum number of units that we could rent out would be 0, and the maximum number that we could rent out would be 100. So we're actually working on this bounded interval for this profit function. We want to maximize the monthly rental profit, so we want to know how many units should be rented out in order to maximize that profit, and we want to know what the maximum profit would be. So in order to do that, we're going to find the derivative of the profit function, which would be minus 20x plus 1760. And we want to set that derivative equal to 0. Okay, and we're going to subtract over or add over 20x to both sides, and we're going to divide both sides by 20. So 1760 divided by 20 gives 88. Alright, now we want to find out which one of these values gives the maximum profit. So we're going to evaluate at the endpoint. So what if we rent out no apartments? Then if we put this into the original profit function, we would end up losing $50,000. So that's a loss. What if we rent out all 100 apartments? So that would be negative 10 times 100 squared plus 1760 times 100 minus 50,000. We'll put that into the calculator as is. And I end up getting $26,000. So this will be a profit of $26,000. And we want to know what happens if we rent out the 88 apartments. We're going to put that also into the calculator as is. So in this case, we would end up making a profit of $27,440. So the maximum profit will be realized when 88 apartments are rented out. The next problem is a little bit more interesting. We want to look at maximizing profit again, but here we're not given the profit function, we're given the demand function, and we're also given the cost function. So in order to maximize profit, we will need to know first of all what is the profit function. Profit is the revenue function minus the cost function. And in order to find the revenue, we take the demand function, and remember that revenue is quantity times price. So we're going to multiply the demand function by x. So our revenue function would be x times negative 0.05x plus 600. So it's x times p, and that's what p equals. And we're going to distribute in the x. Okay, so the profit function then, let's write that out here. The profit function is the revenue function. We're going to subtract off the cost function. And remember that when we subtract off cost, we change the signs of every term in the cost function. So I'm going to go ahead and change the signs, and then we're going to add like terms. Okay, so we're going to combine like terms. Cube function first, and then the square terms. That will give us negative 0.02x squared plus 200x minus 80,000. This is the profit function that we want to maximize, and we have a given interval. We're bounded between 0, an x value of 0, and x value of 12,000. So in order to find the max profit, we need to find the derivative. We're going to use our power rule. And we're going to set this equal to 0. And when we do that, we see that we get something that's not going to factor. We're going to use the quadratic formula. Okay, remember that the quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, the a is what's in front of x squared, the b is what's in front of x, and the c is what's without x. It has no it's just a constant, it has no variable. So we end up getting minus a negative 0.04 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Alright, so we start to simplify. We get a positive 0.04 plus or minus the square root. And we're going to put everything under the square root right in the calculator just as we see it. And I end up getting 0.0064 all over. We're going to multiply 2 times that a value. So we end up getting 4 zeros after the decimal and then 12. And then we're going to take the square root of that value. And I end up getting 0.04 plus or minus 0.08 all over that negative value. And then we're going to separate this into 2 separate x values. So one of the x values is with a positive in between, divided by this negative value. And the other x value will be with the negative in between, all divided by that negative value. Okay, so we put that into our calculator. Okay, we put this into our calculator, end up with 0.12 divided by this value at the bottom. I actually end up with a negative 10,000. And x can't be negative because x represents the number of units. So we're going to ignore this because it doesn't fall within our bounds that x must be between 0 and 12,000. So we're going to put this value also into our calculator. And I get a positive 3,333. We'll go ahead and round to the nearest whole number of units. All right, so once we get that value, we're going to evaluate the profit function at that value and then also the endpoints. Okay, so our profit function looks like this, and we're just going to put this directly into the calculator exactly as we have it written. And I end up getting $290,370.3659. So that's what my calculator shows me. Okay, let's go ahead and round to the nearest dollar. The nearest whole number, I get this value here. All right, we also want to evaluate at the endpoints. So if we put, if we make x 0 number of units, we put that into the profit function, it seems pretty clear that we would be left with negative 80,000. That's definitely not the maximum profit. And what about 12,000? We also want to put that into the profit function as well. So let's see what happens when we produce 12,000 units. And I put all that in my calculator and ended up getting -4 million and some change. So we can clearly see here that the maximum profit would be here. And that profit is maximized when we produce 3,333 units.